Assalamualaikum warahmatullahi wabarakatuh. Welcome grade 8. Today, inshallah, we are going to study geometry revision about the first curriculum of the first term, inshallah. So first of all, we need to talk about the medians of the triangle. If you remember, when we talked about the median, we said that the line segment joining between the vertex in the triangle and the midpoint of the opposite side, so we call it a median. That means any triangle, of course, should have three medians because it has three vertices, so you can join the three medians from each vertex here. From the vertex to the opposite midpoint, so it's a median. CD is a median, BE is a median, AE is a median. All these medians, whatever the type of the triangle, it will have three medians. So all these medians should intersect at only one point. And this one point, we call it point of concurrence. And the point of concurrence divide the median into the ratio 1 to 2 from the base and 2 to 1 from the vertex. So from the direction of the vertex, it's divided into the ratio 2 to 1. From the direction of the base, 1 to 2. If all the median here is 9 centimeters, for example, so I will divide it by 3. So the smaller part, which is only, its ratio is only 1, it will be 3 centimeters. But the bigger part here will be 6, will be its double. That's the part of the ratios between the parts of the median. This is what we already talked about here, 1 to 2 from the median, from the base like this, and 2 to 1 from the median, from the vertex. Then we are going to talk about when you have a right angle triangle. You have some colors about this part in this lesson, which is when you have a right angle triangle and there is a median drawn from this vertex, from the right angle, then the opposite, this median will be half the hypotenuse. The side which is opposite to the right angle, it's called the hypotenuse. Then the median, BD, will be equal to half the hypotenuse AC. If the hypotenuse is 10, then of course BD will be 5. If the hypotenuse is 20, the BD will be 10. So here, if I have a median drawn from a vertex and it's already half the opposite side, it's some vertex and it equal half the opposite side. For example, BD here is 4 and AC is 8. That means B, or the vertex, we write that the vertex is right. So if it's just a median drawn from some vertex and it equals to half the length of the hypotenuse or the opposite side, he didn't say hypotenuse now, so this vertex will be right. What if I have right angle with 30-degree angle also in the same triangle? By the way, this is called the 30-60 triangle. We call it 30-60 triangle. 30-60 triangle because if this angle here is 30, then this angle also here will be 60. That means it's called 30-60 triangle. What to do about this? If you have a 30 angle in the right angle triangle, the side opposite to it, which is AB here, will be, of course, half the hypotenuse AC. If this side here is 5, this should be 10. If this is 2, this should be 4. If this is 4, it will be 2, and so on. So this is the part of the right angle triangle. Then after that, we are going to study an example about this part. You have to remember the ratios or the point of concurrence. What does it do to the medians in the triangle? Okay, I have here in the opposite figure, ABC is a triangle in which E and F are midpoints of AB and AC, respectively. The intersection of these two medians is point M. BC is 8 centimeters, BM is 4 centimeters, CM is 6 centimeters. We need you to find the perimeter of triangle MEF. So be careful in reading everything, every word in the given, because sometimes he give you something or an information here in the given, but he didn't put it on the draw, on the graph. So let's try to talk about it. We need to find the perimeter. So how to find the perimeter? by finding the sum of the three sides. I don't have them, but I know that since E and F are midpoints, that means CE is median and BF also is median. So I can divide these parts into a ratio 1 to 2 from this base, and here also it's 1 to 2 from this base. Also, don't forget there is an information you studied before in grade 7. If you have a line segment joining between two midpoints of two sides in a triangle, it should be parallel to the third side and equal its half. Yes, we have it here, it's FE. FE is half BC. So I will just start writing now. After we talked about this part here, all these parts. First of all, we will say that since E and F are midpoints, he already gave me this information. Midpoints of E is midpoint of AB and F is midpoint of AC. These are two midpoints here. Then I can start with any of the two informations. I will start with writing that then EF will be half the third side BC, which will equal 4 centimeters. That is the first thing to write here. After that, I know that then EC and FB are medians. And since they are medians, I know now they having a point of concurrence. Then M is point of concurrence, because now this point is dividing. They are all intersected at this point, so it's dividing them into a ratio. Then directly here, I can say that FM equals half BM. Yes, because this is 1 and this should be 2, the double. So FM will be the half, which is 2 centimeters. And also ME will be half CM, which is 3 centimeters. Now I found all the three sides now. This is 4, this is 3, this is 2. Adding them, then perimeter of triangle MEF will be 4 plus 3 plus 2, which equals, here it's 5 plus 4 equals 9 centimeters. And now this is the perimeter of this figure. The next part we are going to talk about here is the isosceles triangle. What about the isosceles triangle? You already studied this. If you have a triangle with two sides are equal in length, that means the two angles, the two base angles will be equal in measure. By the way, this angle, we call it the vertex angle. So the base angles are equal in measure. Also, the vice versa. If you have two angles, two base angles are equal in measure, then the two sides here will be equal in length. This is the isosceles triangle. After that, you studied the corollaries of the isosceles triangle. If you have an isosceles triangle and there is a median or a line segment cutting the opposite side in the midpoint, at the midpoint here, which is the median, then you recognize that there's three things that can happen here. First of all, I know that now this line segment is median. It's in the midpoint of the opposite side. So it will be bisecting the vertex and perpendicular to the base. This is the first corollary. The second one, if this line segment, of course, in the isosceles triangle, perpendicular to the base, it will be bisecting the vertex and bisecting the base. So as I told you, we have three things. These three things, if one of them happened, the other two should happen. One of them here is that the line segment is intersecting at the midpoint. It's bisecting the base. So it's bisecting the vertex perpendicular to the base. So I have bisecting base, bisecting vertex, and perpendicular to the base. If it's bisecting the base, it will be bisecting vertex and perpendicular to the base. If it's perpendicular to the base, it will be bisecting vertex, bisecting the base. And at last here, if it's bisecting the vertex, it should be bisecting the base and perpendicular to it. So these three are related together. One of them happened, the other two should happen. But all of this is only in the isosceles triangle. If it's not isosceles, I can't say any of these. The next part here, we are going to talk about an example about this part. We have a shape like this figure here. We have measure angle A equals 100 degree. You have AD parallel to BC. These two lines here are parallel. You have also angle A is 100, BD equals BC, and angle BDC equals 70 degree. Find or prove that triangle ABD, this triangle here, is isosceles. To prove a triangle is isosceles, I have to prove one of two things. You can either prove the two sides are equal in length, or you can prove the two angles are equal in measure. So, okay, I don't have any side length here in this figure. So I only have angles. That will help me. I will have this angle as 70. Yes, you are right in your thinking here. BD equals BC, it's isosceles, then this also equal to the 70. These two angles are equal in measure. These are two base angles. And at the beginning, if you noticed, you have AD parallel to BC. It's letter Z, if you remember them. I will remind you of these angles here. If you have letter F, if you have letter Z, if you have letter U. When I have two parallel lines making letter with a transversal here making letter F, then each two corresponding angles, we say them are corresponding, they are equal in measure. If I have two lines are parallel like this with a transversal, then each two alternate angles making letter Z, each two alternate angles are equal in measure. Also, if you have two lines like this parallel make with a transversal with them making letter U from the same side here, so the sum of the two angles will be 180. They are called supplementary angles. They are supplementary, their sum equals 180, and we call them interior angles. So they are interior angles. Now I found that this is letter Z. Okay, that's all what I need here. It's letter Z. They are alternate angles. I will start writing now. If it's alternate, so this angle should be equal to this one. I found this as 70. I can find it by getting 180 minus their sum equal this angle, which will give me this one. Let's write to get the angle to see what it will be. If they are equal or not, I need to prove this angle and this one equal in measure. So first of all, I will talk about triangle BDC. Since we have BD equals BC, then of course measure angle C equals measure angle CDB, which is 70 degrees. Then measure of angle DBC will be 180 minus 70 plus 70, which equals 140 here, then the result will be 40 degrees. Since we have AD is parallel to BC and DB is the transversal, and the transversal means this is the line joining between these two lines, two parallel lines. Then measure of angle ADB will equal to measure of angle DBC, which is already 40. I found it here, so it will be 40 degrees. Now let's talk about this part here. Then measure of angle ABD, I don't know its measure yet. It will be 180 minus 100 plus the 40 we got now, which will be also 40 degrees. Now I finally can say that measure angle ABD is equal to measure of angle ADB, which is 40 degrees. Then triangle ABD is isosceles. Okay, I think you got it now. Let's go to the next part. We are going to talk about the equilateral triangle. The equilateral triangle, of course, you remember that it's a triangle that all its sides are equal in length and all its angles also are equal in measure. They are 60, 60, 60. I need you to remember everything about the equilateral triangle. Also remember that if there is exterior angle in the equilateral triangle, its measure will be 120 degrees. You can find a question like this in the exam. The exterior angle of any equilateral triangle, its measure equal 120 degrees. If there is any isosceles triangle with the 60-degree angle in it, it will be equilateral. Why? Because its base angle here, the other base will be 60, the remainder from the 180 will be 60. If it's a vertex, yes, the remainder will be 180 minus 60 and divide the result by 2. Yep, each one will be 60. So any isosceles triangle will with a 60-degree angle will be equilateral. Then the medians in the isosceles triangle are in the equilateral triangle are axes of symmetry. So the equilateral triangle has 3 axes of symmetry. Do you remember the isosceles has how many? Yeah, it has 1 axis of symmetry. If it's isosceles only, it will have only one axis of symmetry. But if it's equilateral, now it's 3 axes of symmetry. And the scalene, all the sides are different. It has 0 axis of symmetry. So all the axes of symmetry here are also medians in the triangle. So it has 3 medians, which are 3 axes of symmetry, because they are all perpendicular at the midpoint. And that's what we are going to talk about for the axis of symmetries after we finish this exam. We have here this figure, measure angle C is 40 degrees. It's a equilateral triangle ABD, DC equals BC. And we need to find measure angle ADC, all this angle here. It's easy, I think. We can talk about this triangle first. It's equilateral, so they are all 60, 60, 60. It's isosceles here. Take the 40, divide the result by 2. You can find the other 2 angles. Let's try doing it. So in triangle ABD, here you have, since triangle ABD or ADB as it's written here, ABD is equilateral. Then of course measure angle A equals measure of angle ADB equals measure of angle DBA, which should be 60 degrees. Then in triangle DCB, since DC equals CB, and let's write also measure angle C equals 40 degrees, then measure of angle CDB will be equal to measure of angle CBD, which is 180 minus 40, the vertex angle, and divide the result by 2. 180 minus 40, it's 140. 140 divided by 2, each one will be 70 degrees. So this angle here is 70, this angle here is 70. Then measure of angle ADC will be the sum of these 2 angles together, 70 plus 60. So it will be 130 degrees. Let's talk about something else here. It's the axis of symmetry. As I told you, we are going to talk about it. Axis of symmetry of any line segment. It is the perpendicular to this line segment at the midpoint. So it's perpendicular and bisector. Then, if you try to join from any point at the axis of symmetry, like D here, to the terminals of the line segment, terminals mean the start and the end. Which one can, any of them can be the start and the end. So the line segment joining from any point to on the axis of symmetry to the terminals of the line segment, they should be equal in distance. They should be equidistant or equal in length. We call it, or we say that from any point on the axis of symmetry or any point on the axis of symmetry should be equidistance from the terminals of the terminals of the line segment. Equidistance means they are at equal distance. They are equal in length. So AD equals BD, AC equals BC. If there is a point here, for example, I don't know, of course, the relation between CE and CD. There is nothing related with this one. It's only about the point on the axis and the terminals of the line segment. EA is equal to EB, AD equals BD, and so on. This is the part of the axis of symmetry. Then, if you have an exercise like this one, BA equals AC, or AB equals AC, EB equals EC also, their intersection here with BC equals point D. Prove that AE is the axis of symmetry of BC. That's easy. You can notice that it's at equal distances from the terminals of the line segment. So it's already an axis of symmetry for this. So I will say that since AB equals AC and EB equals EC, then of course AE as a straight line will be axis of BC line segment because it's at equal distances from its terminals. Then we need to prove that BD equals DC. It's a straight line, and the intersection here at point D, since AE intersects BC at point D, then of course D will be the midpoint, then AD will be perpendicular to BC, and D is midpoint of BC. Or also you can say that since it's axis of symmetry, then of course BD equals DC, because D now is a point belonging to the axis of symmetry. Then also it will be at equal distance from the terminals of the line segment. Let's see something else here to talk about. This is the inequality relation in the triangle. This is the last unit in the triangle, in the geometry here for this term, inshallah. So the inequality in the triangle means what? It means when you have any two sides, they are not equal in length, the greatest side or the longest side, of course, will be opposite to the greater angle in measure. Greater in measure. And also the smaller side or the shortest side will be opposite to the smaller angle in measure. Then if you noticed here ABC, you can notice that by your side here, yes, AC is more than AB. So angle C will be less than angle B. That's what we needed to talk with you about. So now we are going to get the intervals. Let me explain it here. To get any side, any third side in the triangle, any third side in the triangle, it should be between the difference and the sum of the other two sides. Because we will explain an exercise about this later. So you have to know everything about the inequalities. So the inequalities here, it means here you have a third side, it should be between more than the difference and less than the sum, between the difference and the sum. It can't equal the difference, and also it can't equal the sum. So if I wanted to get a third side, you have to know the other two sides. First of all, before we talk about this part, let's get XYZ here is a triangle. Measure angle X is 40, measure angle Y is 80. Order the length of the sides of the triangle. Here I'm trying to order the length of the sides according to the angles. So I have measure angle X equals 40 degree. And measure of angle Y already is 80 degree. I can't complete ordering them until I find the third angle. Measure angle Z. So measure angle Z will be 180 minus 80 plus 40. Of course, using calculator, it will be 60 degree. If you try to draw this triangle, the angle here, let's say it's x, y, z, y here, y should be the greatest one. So it's 80, angle z is 60. Smaller one. Okay, I will give you a hint that can help you a lot. Here it's x, y, z. So it's 40, or it is the smallest one, or I need to talk about x. Remove the x from all the three sides of the triangle, the 3 points, the 3 vertices of the triangle. I need to talk about x, the side opposite to it, the missing letters, it's y, z. The side opposite to y, it will be x, z. The side opposite to z, it will be x, y, and so on. So let's try to arrange them now. First of all, I need to arrange or order these angles. Ascending, remember that ascending means from the smallest to the greatest, unlike descending from the greatest to the smallest. So ascending here, I will arrange the angles first. Measure angle x, it's less than measure angle z, which is less than measure of angle y. Then the opposite side to x, yes, you can see it from the drawing, or you can say it, as I told you now, the missing letter. Remove x, now you have yz. Less than, remove z, it will be xy. I don't need to think even for this one. Here y, the opposite one, it will be xz. So now I arrange it or ordered the side lengths according to the angles, using the angles here, ascending order. As I was telling you here, let's talk about the arranging the angles according to the sides. But here, for example, you have 6, 7, 8, arranging them ascendingly. By your luck here, they are already arranged. I can say AB here is more than, less than AC, less than BC. BC is the greatest one. Which side is opposite to AB? AB, it's opposite to measure angle C. AC is opposite to measure angle B, and BC is opposite to measure angle A. So this is arranging the angles ascendingly, from the smallest one to the greatest one. I want to talk with you also about the part if you have, for example, 3, 7, and L. It's an example here. How to get the third side. I just explained it for you, and I will remind you of it again. To get the third side, it should be between the difference of the other two sides and their sum. It's an inequality here, and it will be open interval. Open interval between the difference and the sum. It can't equal the difference, it can't equal the sum. So I'm not making it as closed interval. It should be open like this. So the difference between here, any two sides, like 7 and 3, their difference will be 4. 7 minus 3 equals 4. 7 plus 3, it will be 10. This is the difference between them. So as you can see here, we have the third side should be between 4 and 10. What if he told me that this triangle is isosceles, for example? If it's isosceles, as you know, that the third side should be equal to one of them. I can't take it to be 3, because 3 is not between 4 and 10. It should be 7. If triangle is isosceles, then L will be, of course, should be 7, because it should be equal to one of the two sides he gives me. Now, that's all about this part, about this curriculum in geometry. Thank you for watching. See you later, inshallah.